in D block elements for NEET JEE purpose, exchange energy. Exchange energy very successfully explained by the main important case is Cr plus Mn plus chromium atomic number 24, manganese 25. It is across the series. Left to right, generally ionization enthalpies increases. Okay, because nuclear charge increases. Then Cr plus electron configuration, we know that Cr plus electron configuration is 3d 5 4s 0, and Mn plus configuration is 3d 5 4s 1. Here they ask the question, Cr plus contains more ionization enthalpy, means second ionization, IE2. IE2, second ionization enthalpy of chromium is more than manganese second ionization enthalpy. Explain. And what is the reason? Statement type question or assertion reason type question also. Very most important question. Statement or assertion or whatever it is. Match the column or multiple choice question also. Now see here. Even both are having d5 electron configuration, it is also d5 electron configuration. Therefore, symmetrical configuration d orbital, it is also symmetrical electron configuration. Symmetrical means stable half field, famous, stable half field. It is also stable half field. Both are half field stable, but left to right ionization enthalpy is increased, but chromium to manganese second ionization enthalpy decrease. It is explained by only exchange energy, that's all. Any other one, nuclear charge, whatever it is, anyone doesn't explain. Only exchange energy can explain why chromium second ionization enthalpy more than manganese second ionization enthalpy. So before going to this explanation, we must and should know the what is exchange energy. EE. EE means exchange energy. Now, it is directly proportional to, see that, need not to remember the what is the definition. Exchange energy is directly proportional to number of electrons with parallel spin. Parallel spin. Parallel spin means, for example, with this electron spin plus of upward and this electron spin downward minus of. These are not parallel spin. For example, this electron spin upward plus of and this electron spin also upward plus of. These two electrons having parallel spin, same spin. This is the exchange energy. And more number of electrons with parallel spin is more exchange energy, directly proportional to. First point about the exchange energy. Remember this. Second point about the exchange energy is, second point, stability of any ion or atom, stability of an electron configuration or atom or ion, metal, we are in D block, stability of M or any M plus ion is directly proportional to loss of exchange energy. These two are the important factors regarding exchange energy. First point, exchange energy directly proportional to number of electrons with parallel spin. Second point, stability of any M metal or metal ion directly proportional to loss of exchange energy. If any, in conversion, if a metal or metal ion loses more exchange energy, loses more exchange energy, that is more stable. If any metal loses less exchange energy, less stable, that is the meaning. Now, based on these two factors, then we can explain this example. These two factors, remember this. Then we can apply these 2 points about this example. Now see that. How it is applicable. Chromium plus. We know that 3D series. Manganese also 3D series. Chromium atomic number 25, manganese 25. And left to right we discuss. Okay. Now see here. Chromium plus and manganese plus formation. How the exchange energy discussion. Chromium plus. Here chromium plus, how it is formed, you can, before plus, removal of one electron. See that. From chromium metal, just remove the one electron, it gets chromium plus. We know that. Chromium electron configuration, we know that 3d5. 1 with parallel, this spin, upward 2, 3, 4 and 5. This is the 3D. And 4s1. 4s orbital, 1 electron. Chromium. Now when it is converted into chromium plus configuration, this electron loses. Now see here. 1, 2, 3, 4, 5. And s orbital 0. Here we can calculate the exchange energy. Exchange energy is directly proportional to electrons with parallel spin. Here 1, 2, 3, 4, 5, 6 electrons parallel. 6 electrons exchange energy because 6 electrons with parallel spin. Then come to here 1, 2, 3, 4, 5 electrons only. Here 5 electrons and exchange energy. 5 electrons only involved for exchange energy. We know that exchange energy is directly proportional to number of electrons with parallel spin. Here exchange energy 1, 2, 3, 4, 5, 6 electrons with parallel spin. And here 1, 2, 3, 5 electrons only parallel spin. Therefore, exchange energy direct proportional to this factor means this contains more exchange energy. More exchange energy. It contains less exchange energy. Less exchange energy. Reason is only 5 electrons with parallel spin. Here reason is 6 electrons with parallel spin. More number of electrons with parallel spin, therefore more exchange energy. Less number of electrons with parallel spin, therefore less exchange energy. Now, in this conversion, this chromium more exchange energy, less exchange energy means it loses, loss of exchange energy takes place. In this conversion, loss of EE. EE means exchange energy. Then this is the case 1 explanation. Case 1 explanation. Come to manganese plus, Mn plus. Mn plus means Mn convert into Mn plus. Okay. Now, what is the manganese electron configuration? D5 S2. The 3D5, 3D orbital 5 electrons. 1, 2, 3, 4 with 5 electrons. 3D. And 4s orbital 2 electrons. Now see here in case of Mn plus, this is about Mn. In case of Mn plus, written here Mn plus. Mn plus I make the red marker, okay. This is Mn plus now. Mn plus means 3d5, 1, 2, 3, 4, 5. This is the 3d. And 1 electron you can remove. This is Mn to Mn plus, 1 electron remove. Therefore, 4s orbital, 1 electron. Now in manganese, 1, 2, 3, 4, 5 electrons exchange energy only can consider, because one upward, one downward cancelled, mutual cancellation. Therefore, here in case of manganese, 5 electrons exchange energy only consider. But in case of Mn plus, 1, 2, 3, 4, 5 and the 6 electrons so upward. 6 electrons exchange energy consider. And here 1 electron removed here also. In case of manganese, 5 electrons exchange energy. In case of Mn plus, 6 electrons exchange energy. We know that exchange energy directly proportional to number of electrons with parallel spin. Here 5 electrons parallel spin, here 6 electrons parallel spin. But 5 electrons are less number. Therefore, manganese having less exchange energy because exchange energy from 5 electrons only. Come to Mn plus, here 6 electrons exchange energy consider. 6 electrons exchange energy. 6 electrons EE. EE means exchange energy. Therefore, here less exchange energy is less. Here exchange energy is more. More exchange energy. More exchange energy. This configuration belongs to Mn plus now. 6 electrons parallel spin, 1, 2, 3, 4, 5, 6 electrons parallel spin, but in manganese 5 electrons parallel spin. Less to more means it is not loss of exchange energy, it is gain of exchange energy. In case of this, gain of exchange energy. But we know that I give the 2 points regarding exchange energy. First point is exchange energy is directly proportional to number of electrons with parallel spin. Second point is stability is directly proportional to loss of exchange energy. If in any conversion, if exchange energy more loss, that is the more stable. But here exchange energy is gain. 5 electrons with parallel spin, 6 electrons with parallel spin, gain. But in case of chromium, exchange energy loss. What is the product in this? Chromium plus, here also product Mn plus. And in formation of Cr plus, it loses exchange energy. In formation of Mn plus, it gains exchange energy. This is the main important difference. Therefore, this chromium plus is the more stable than compared to Mn plus. That's why this is more ionization enthalpy. That is, and further 1 electron removed from Cr plus, that is the second ionization enthalpy. More second ionization enthalpy of chromium is explained by the exchange energy concept. That's why, due to this reason, chromium contains more second ionization enthalpy than compared to manganese. That is explained by only exchange energy. Therefore, loss of exchange energy takes place in manganese only. Sorry, chromium only. In manganese, gain of exchange energy. Manganese, see that once again here, manganese example. It is the D5, 1, 2, 3, 4, 5 and 4s. Here only exchange energy 5 electrons with parallel spin. 5 electrons with parallel spin. Parallel spin. Parallel spin. When it is converted into, at removal of one electron, it converts into Mn plus. What is the Mn plus configuration? This is Mn plus configuration. 1, 2, 3, 4, 5 electrons with same spin, and also 4s also 1 electron. Here 6 electrons with parallel spin. With parallel spin. Parallel spin. Here 5 electrons with parallel spin, 6 electrons with parallel spin. Therefore, in this case, this is the more exchange energy because more electrons with parallel spin. More exchange energy, E. And 5 electrons with parallel spin and less electrons with parallel spin. Therefore, it is the less exchange energy. Less exchange energy. And less to more means it gain the exchange energy. That's why this is the less stable. Less stable. And from less stable electron configuration, we can easily remove the electron. Therefore, its ionization enthalpy is less, low. Low ionization enthalpy. Therefore, this is the explanation about Cr and manganese, very important. But in case of manganese plus 2 and iron plus 2, exchange energy also, exchange energy concept, only 2 pairs. This is the first pair. Second pair is the Mn plus 2 and Fe plus 2. In this case, simply I can explain the 2 pairs also. Listen, Mn plus 2 and Fe plus 2. Mn plus 2 and Fe plus 2. In this case, further electron removal. Mn plus 2 formation means it comes from Mn. Okay. Manganese. We know that D5S2. 1, 2, 3, 4, 5 and 4s. And it is from Mn plus. We need Mn plus 2 means its mother molecule ion is Mn plus. Mn plus means here 1 electron only. This convert into Mn plus 2. Okay. In this one electron removed. And in this formation, Mn plus 2 means D5 configuration. 1, 2, 3, 4, 5 and 4s 0. Here exchange energy with 6 electrons. 6 electrons parallel spin. Here 5 electrons parallel spin. Therefore 6 electrons, 5 electrons, 1 electrons less. Therefore loss of exchange energy here. Loss of exchange energy. Okay. Then next see this Fe plus 2. Now we discussed about the I3. In this one which is having more I300. I3 means third ionization enthalpy. Very important. For this one Fe plus 2. Fe plus 2 is formed from, what is its mother ion? Fe plus 1. From this one only 1 electron removed. 1 electron removed. Then Fe plus 1 means, what is the configuration? It is the 3d orbital 6 electrons, 4s orbital 1 electron. Okay. 3d orbital 6 electrons arranged like this. 1, 2, 3, 4, 5 and 6. And 4 electrons. 4s orbital 1, right. 4s orbital 1. 1, 2, 3, 4, 5 electrons with parallel spin. And after removal of electron, Fe plus 2 means 3d6. 1, 2, 3, 4, 5 and 6. Now here what happens in this one? 4 electrons. 4 electrons with parallel spin. Therefore here also loss of exchange energy from 1 electron. Loss of exchange energy in both cases takes place. Here loss of exchange energy in the formation of Mn plus 2. In formation of Fe plus 2 also loss of exchange energy. But That's why in this case exchange energy not explained by the further electron removal. And I3 means electron removed from this one. No? Here also I3 means electron removed from this. In both formation, loss of exchange energy takes place from one electron only. And the same amount of exchange energy can lose both ions. In this case, symmetrical electron configuration can explained by the ionization enthalpy. Here, 5 electrons symmetrical and stable off field configuration. Therefore, this is the stable off field configuration. This is not stable, D6. Therefore, this is unstable compared to that. Unstable electron configuration. But electron again removed from the stable electron configuration required more energy. More energy required to remove this electron, but less energy required to remove this electron. That's why I3 is more ionization enthalpy, more I3, and but here less I3. Therefore, they can ask which factor can explain for the third ionization enthalpies for manganese and iron. And exchange energy not explained, symmetrical electron configuration can explain. But in case of chromium and manganese, for second ionization enthalpy of chromium is greater than manganese, which factor explained means symmetrical electron configuration not explained, exchange energy can explained. Very important difference. This is the D block elements for NEET, JEE and students for this one, even advanced also. This is Gurram Shekhar, Chemist Tracks.